Today we'll be discussing ray optics and optical instruments. This is a chapter which is given in your NCERT textbooks. So the content that I will cover will be as per your textbook. Now, first of all, when we talk of ray optics, so you can see there are two words, ray and optics. Now, optics refers to light, and over here when we are looking at light, we are talking of the spectrum, the part of the electromagnetic spectrum that we can see, which is from about 400 nanometers to 750 nanometers. Because if there's something beyond this, then you can't see it. For instance, you have infrared, which is, so you can feel the heat, but you can't see something placed in those waves. You have UV light, so you know that you cannot see something placed in that light. Now we are referring to this part of the spectrum, which is from 400 nanometer to about 750 nanometers. And why the word ray? Ray, because here we refer to light as a ray of light. We say that it moves in a straight line. So suppose this is a source of light. So you have rays emanating in all directions, which means you're just denoting light traveling in different directions. So in ray optics, we represent light by a straight line with an arrow, which gives us the direction in which light is traveling. And the speed of light, you probably already know this, is 3 into 10 to the power 8 meters per second. That is the speed of light in vacuum. So now let's look at the reflection of light from either a plane mirror, and this is the non-reflecting side, or a curved mirror. Let's say we are looking at a concave mirror. Of course, the mirror could also be convex. Now, so our heading would be the reflection of light from either a plane mirror or a curved mirror. So how do you draw the incident and the reflected ray? Let's say this is the incident ray. Now you would draw the normal at this point. Normal means the perpendicular to the reflecting surface, and this is the angle of incidence, denoting that by I. And the angle of incidence and the angle of reflection are equal. So I and R are equal. Now the incident ray, the reflected ray, and the normal are all in the same plane. This would mean that if you vary the plane, see the plane as such, if you take, this is the plane and this as the reflecting surface, then this is in the same plane. The incident ray, the reflected ray, and the normal, they are all in the same plane. Now to understand this, what you can do is you can vary the plane. Think of it like a piece of cardboard. So all of them, the incident, reflected ray, and the normal, all will lie on that piece of cardboard however you turn it or orient it. Now coming back to this, the angle of incidence, this is a law, but for our purpose, when we are taking rays, we don't really need this, or we don't need to think much about this, that all of them are in the same plane. That is something you just need to know. Now see, it's simple to think of the normal or a perpendicular to a plane mirror. In case of a curved mirror, it's a little more difficult. Now, a curved mirror, this would be the center of the sphere of which the curved surface is a part. Now, if I were to join this by a straight line and say you want to find out the angle at which the ray gets reflected at some place at the surface of the mirror. So you need to know the normal. Just a minute. Now this is the normal, this is the straight line. So how do we know this is the normal to this tiny little mirror? The mirror is a reflecting surface. A curved mirror is a reflecting surface, but you can think of it as made up of infinite tiny plane mirrors. So each of these little mirrors are reflecting light which falls in that region. Suppose light falls here, this mirror is reflecting. If light falls here, this mirror is reflecting. And how do you draw the normal? Because we know that the angle of incidence and reflection are with the normal. So at this point you connect this with a straight line to the center of the mirror. So this straight line would be the normal to the mirror, because this is the center, this is the straight line, and this is the tangent. So the tangent over here is the reflecting surface, and this straight line is always perpendicular to the mirror. So when you have a curved mirror and at any point you want to draw the angle of incidence and the angle of reflection, so this is I and this is R, then at that point you join that to the center of the mirror, so you know this is the normal and this is the angle of incidence and this is the angle of reflection, and this is going to be equal.